Alright, and our last types of examples in which we have to determine the value given a function. Remember from class, this does not mean f times x, it's read f of x, function of x. And if we want a different function, still the same concept, we just use a different letter. So this is read g of x. It's still a function, we just can't use the same f of x because this is the only f of x in this case. So we need a different one, g of x. So for number 3, again, some of these examples you may have done in class. Some of them might be a little bit different. So in number 3, f of negative 5. So if I have we're going to use the f function, right? I'm trying to determine what the f of negative 5 is. So notice the negative 5 has now replaced the x. I'm going to do the same on the right side. I'm going to replace the x with a negative 5. There's nothing to do on this side. I'm not going to say that it's negative 5 times f. We are simply figuring out what the f of negative 5 is. The work comes on the right side. 2 times negative 5 is negative 10. Negative 10 minus 4 is negative 14. So the f of negative 5 equals negative 14. So all this means is that when I plug negative 5 into my f function, the output or the answer is negative 14. So now let's take a look at number 4. We're using the g function here. So notice negative 3 has now replaced the x. So I'm going to replace the x on the right side with negative 3 as well. Okay, so again, nothing to do on the left side. We're simply finding what the g of negative 3 is. Negative 3 squared is negative 3 times negative 3, so that is positive 9. Negative 4 times negative 3 is positive 12, so we have 9 plus 12. So the g of negative 3 is 21. In number 8, only difference is that we have a fraction. The x is replaced by 1/4. I'm going to use the f function because it's f of 1/4. So the f of 1/4 equals 2 times 1/4 minus 4. Two times 1/4 is 2/4, or reduce it to just a half. So I have 1/2 minus 4. And 1/2 minus 4 would be negative 3.5. And the last one on this page, the g of 1/4. So again, 1/4 has replaced the x, and I'm going to do the same thing into the function. So we have 1/4 squared, so that's 1/4 times 1/4. That's not 2/4. It's not saying multiply it by 2, it's saying square it. So 1/4 times 1/4 is actually 1/16. I have 4 times a fourth. Well, 4 times a fourth is just 1. So that'd be minus 1. So I have 1/16 minus 1. I'm going to change the 1 to 16/16. 1/16 minus 16/16 is negative 15/16. Okay, last slide. Same type of problems. We're going to use the same f of x function, the same g of x function. Only difference is that now we have in 11 and 12 expressions with variables. Not much is really going to change though. I'm going to use the f function. Notice that k plus 1 has replaced my x. So I'm going to replace the x on the right side with k plus 1 as well. So I'm going to use parentheses, substituting k plus 1 in for x. Again, nothing to do on the left side. Distribute the 2 into the parentheses. 2 times k is 2k, plus 2 times 1, which is 2. Bring your minus 4 down. Now we just have one small thing to simplify here. I have 2 minus 4. Well, that would be negative 2. So 2k minus 2. So the f of k plus 1 equals 2k minus 2. Number 12. We are finding the g of 2n, so we're going to use the g function. The 2n has replaced my x, and so the 2n will replace the x's on the right side. So I'm going to write that. Make sure you use parentheses here. Should always use parentheses when you are substituting in a value and for a variable. Remember the law of exponents. 2 is going to distribute to both of these factors, so 2 squared, 4, n squared. 4 times 2n is 8n, so minus 8n. And I am done because these are not like terms. N squared and n have different exponents. We cannot combine them any further. Okay, in our last example, first we need to find the f of 2, which I've already done. Use your f function to find what the f of 2 is, and it's 0. And then all we need to do is add 3 to it at the end. 0 plus 3 is 3.